Welcome to the Automated Geospatial Watershed Assessment Tool, AGWA, video series. AGWA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGWA is available at www.tucson.ars.ag.gov/agwa. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the third video in this series, Delineate a Watershed. This video follows the AGWA Mountain Fire tutorial. AGWA Video 2 showed how to install AGWA, download the tutorial and GIS data from the AGWA website, and provided some background on the mountain fire. The mountain fire tutorial demonstrates how to use AGWA to evaluate the hydrologic effects of land cover change from fire using the burn severity tool. You'll run AGWA with the Kinneros 2 hydrologic model before and after the mountain fire, and then view the resulting changes to runoff, peak flow, and sediment yield. This tutorial uses AGWA version 10.7-3.9.5.2279 and ArcGIS 10.7.1 with the 2019 version of the Introduction to AGWA for Bare Scenarios Mountain Fire tutorial. You can use any version of ArcGIS as long as you download the correct version of AGWA from the website. AGWA Watershed Delineation creates a feature class that represents an entire area, the watershed, that drains to a user-specified outlet. We can use AGWA to determine the outlet location. First, we create the flow direction, flow accumulation, and stream network rasters. The flow direction raster shows the direction of surface flow and is created from the DEM. In the flow accumulation raster, the value of each cell represents the total number of all cells flowing into it. It's created from the flow direction raster. The stream network raster is created from the flow accumulation raster and is used to determine the outlet of the watershed. This image shows the Andreas Canyon watershed used for the mountain fire tutorial with the stream network created from the flow accumulation raster, and the red arrow pointing to the watershed outlet, the blue dot, located on the stream network. To delineate the watershed, go to AGWA Tools, Delineation Options, Delineate Watershed. In the delineator form that opens, in the Output Location box, the workspace will already be selected, Tutorial_Mountain Fire. Name the geodatabase Andreas Canyon. AGWA stores all of the data it creates in this geodatabase. In the Input Rasters box, for the DEM, select DEM_MTNFIRE from the drop-down menu. We'll need to fill this DEM to fill the sinks and depressions to create a hydrologically correct DEM so the models run properly. Click Fill. In the Input Rasters box, go to the FD tab, the Flow Direction tab, and click Create. AGWA will automatically name this raster. Next, go to the FA tab, the Flow Accumulation tab, and click Create. In the Stream Network tab, enter a threshold of 2500 and name the raster STRM2500. This is the number of cells used to initiate the first order streams. Click Create. Next, we'll identify the watershed outlet. In the Outlet Identification box, in the Point Theme tab, select the VARS feature class. We'll use the VARS layer to identify the road culvert as the watershed outlet. Click the Select Features tool to select which point to use. Use the Select Features tool to draw a rectangle around the VAR farthest to the east. This is the road culvert and is the watershed outlet. Click Delineate. Your watershed should look like this image. This is the Andreas Canyon watershed. Save your map document and continue. Agua provides another method for identifying the watershed outlet. In the Outlet Identification box, in the User Defined tab, use the Select tool to draw a circle around the location of your watershed outlet on the stream network. Click Delineate. If you selected a point near the road culvert VAR, your watershed should look similar to this image. The next video will show how to discretize a watershed.